You think the universe is a place, like a giant room, and you're inside it. Fine. But why? Why does your mind insist there's an outside? If you travel far enough, what do you hit? If space keeps going, what is it going into? And if there's no edge, how is that even possible? Most people don't actually answer that. They repeat one word, infinite. And they treat that like it solves the problem. But that's not an answer. That's a label. Because infinite doesn't tell you what happens when you reach the end. It doesn't tell you what the universe is. It just lets you stop asking. And the moment you seriously ask where the universe ends, your model of space stops working. So let's do it. Where is the edge? And if there is no edge, how can that make sense? Because the truth is, the universe has no edge for the same reason the Earth has no edge. Not because it's endless, not because it goes on forever, but because the idea of an edge is the wrong kind of idea. It doesn't apply. Let me show you. Start with something simple. A video game. In a video game world, you run to the edge of the map. You hit an invisible wall and the game refuses to render beyond it. Your brain loves that because your brain understands rooms and borders and boundaries. Everywhere you've ever lived had edges. A house has walls. A city has limits. A country has borders. Even a piece of paper has an edge. So when you imagine the universe, you imagine the biggest thing you've ever seen. And then you automatically imagine the biggest wall you've ever seen. A cosmic wall, a final boundary, a place where reality stops. But wait, look at what you're imagining. You're imagining the universe sitting inside something bigger, like a box sitting inside a larger room, a container, an outside space where the universe is located. And that feels natural because you've never experienced anything else. Everything you've ever seen has been inside something. But if the universe is everything, what is it inside? If space is the thing that holds objects, what holds space? You can feel the trap. The question is trying to force reality into a picture that might not exist. So let's take your intuition seriously. Let's actually chase it. Imagine you're traveling, not with engines, just as a thought experiment. You pick a direction, any direction, and you go, you pass stars, leave galaxies behind, and keep going. Because you're trying to find the edge. You're trying to find the wall, the end. So where is it? At first your mind says it must be far away, somewhere out there, beyond what we can reach, beyond what we can see. But that's not the real problem. The problem isn't distance, it's meaning. What would an edge actually be? Would there be a wall of blackness, a boundary line, a curtain? And then what? Could you step past it? If you could, what would you be stepping into? Because the moment you imagine beyond the edge, you've already created a larger space, a larger container, a bigger universe outside the universe. So to truly have an edge, you need something stranger. You need a boundary where beyond doesn't exist, a place where the concept stops applying. And that's the first clue, because edge is a concept that works for some kinds of things, but not for others. Edges exist on surfaces. Edges are about boundaries, and boundaries are about things that sit inside something else. A lake has an edge because it sits inside land. A sheet of paper has an edge because it sits inside air. A map has an edge because it sits inside the table it's drawn on. But a world might not have an edge, not if the world is the whole thing. To see what I mean, imagine you're an ant, not a human, an ant. Your entire universe is the surface of the earth. You don't fly, you don't see the globe, you just walk. You walk forward and forward and forward. You cross deserts, oceans, mountains. You keep going. Now here's the question. Do you ever reach the edge of the earth? No. Not because the earth is infinite. It isn't. It has a size. It has a limited amount of surface. and yet you never reach an edge. No wall, no border, no end. Because a surface can be finite without having a boundary. Finite doesn't mean bounded. That one fact breaks the room model, because your intuition secretly believes this. If something is finite, it must have an edge. If something has no edge, it must be infinite, and both parts are wrong. Finite things can have no edge. If the geometry is different, now scale that mistake up one dimension, because the universe isn't a two-dimensional surface. It's three-dimensional space, and your brain is trying to treat it like a box, like a room, like a container. So here's the first structural reframe. The universe isn't a thing inside space. It's the space, that's the shift. The universe is not an object sitting somewhere, it's the somewhere. So asking for the edge of the universe is like asking for the edge of north. Think about it. You can walk north, you can keep walking north, and eventually you reach a place where something strange happens, the North Pole. At the North Pole, north isn't a direction you can continue into, not because there's a wall, not because the world ends, but because north is a rule that stops applying. There is no more north. The question collapses. So when you ask what's beyond the edge of the universe, you're doing the same thing. You're taking an intuition that works locally and applying it to the structure of reality itself. You're assuming there must be a direction called out. But out is only a direction when you're embedded in something bigger. Outward from a sphere exists because the sphere sits in a larger space. Outward from a room exists because the room sits in a larger building. Outward from a map exists because the map sits in the air. But if the universe is all of space, there is no outward, no into, no container. So here's the first payoff you can feel. The universe has no edge because edge assumes an outside. And the universe may not have an outside, but wait, you might still try to escape with one word. Fine, it's infinite. And yes, maybe it is. Maybe space is flat and infinite and goes on forever. But notice what that would mean. It wouldn't mean the edge is far away. It would mean there is no boundary at all. No last place, no final coordinate. So whether the universe is infinite or finite, but unbounded, either way, there's no edge. The absence of an edge does not tell you which one it is. It only tells you the room model is wrong. So now we climb the next rung, because the next trap is subtle. Your mind says, okay, no edge, but it still insists the universe must be somewhere. It insists there must be a larger empty space it's sitting inside, a background stage, a cosmic container, because your mind has never met anything else, and this is where people start imagining expansion the wrong way. They imagine the universe expanding like a balloon into surrounding air, into something. But expansion doesn't mean moving into. Not here. Expansion means the distances inside the universe change. Space itself stretches, not into a larger emptiness, just stretches. Now here's the part people get wrong. They imagine expansion like an explosion, like everything started at one point and flew outward into empty space. But that picture secretly smuggles in a center, a privileged location, a place where the universe began. And that's not what the data describes. Expansion is not galaxies moving through space away from a central blast. It's the distance between galaxies increasing everywhere all at once. Here's another way to feel it. Imagine dots drawn on a rubber sheet. Stretch the sheet. Every dot moves away from every other dot. From the perspective of any dot, it looks like everything else is running away. And every dot gets the same story. That's how cosmic expansion behaves. Not everything is moving away from a center. Everything is moving away from everything, which means the universe doesn't just lack an edge, it also lacks a special middle, no center, no outer shell, no direction that counts as out. just a geometry whose scale changes with time. And once you see that, you realize why the room model fails so hard. Rooms always have centers and walls. Expansion inside a room means pushing into the room's air. But the universe isn't expanding inside anything. It's the coordinate grid itself changing. So the universe gives you the second payoff. Beyond might not be a valid coordinate. Now at this point you might say, okay, but I still want to know what it looks like. Is space curved, flat, infinite? Does it loop back around? That's the right question. Because now you're asking about geometry, and geometry is something we can test. So here are the two big possibilities. Option one, space is infinite and flat, no edge because there is no boundary. Option two, space is finite but unbounded. It closes back on itself. No edge because every direction continues. Different geometry, same result, no border. And if that sounds abstract, here's a version your intuition can actually hold. Imagine a simple video game world again, not one with walls, one where the edges wrap. You walk off the right side of the screen and you reappear on the left. No boundary, no wall, no cliff, just continuity. From inside that world, there's no outside. There's no place you could point to and say space ends here. And yet the world is not infinite, it has a finite size. You can cross it. The only difference is that straight lines don't behave the way your room brain expects. In a wrapped space, you can travel forever and still return to where you started. Not because you turned around, not because you hit an edge, because space itself is connected. That's topology. It's not about how space bends locally. It's about how space is stitched together globally. And it gives you a third option your intuition hates. A universe that is finite, has no edge, and yet still has a total size. Not a box, a loop, a self-contained geometry. And one more thing drops out of that. If space can be finite without an edge, it can also be finite without a center. Your room brain assumes finite means there's a middle, a best seat in the theater, a point everything is arranged around. But look back at the ant on the earth. On the surface, where is the center? Pick any spot and call it the middle and it's instantly wrong. Walk far enough in any direction and you can get arbitrarily far from it. The only real center of the earth is inside the planet, in the volume, not on the surface the ant lives in. So from the ant's point of view, the center of my world isn't a place you can stand. It's not part of the world at all. That's the same move the universe can pull. A three-dimensional space can be finite and self-contained in a way that has no special location inside it, no cosmic downtown, no privileged coordinate, no point you could mark and say this is the middle of everything. There might be a center in some higher description. But if that outside description isn't physically real, then the center isn't physically real either. Inside the universe, every place can be ordinary. Everywhere can be the same kind of place. Finite without edges, ordered without a middle. And that's why the explosion picture is so misleading. Explosions have centers. They happen in rooms, they expand into air, they leave a middle behind. Cosmic expansion doesn't behave like that because the universe isn't an object in a container. It's the container. And once you see it, the lack of an edge stops being mysterious. It becomes inevitable. And here's the part that ruins the intuitive version of the story. Even if space is finite, the loop could be so large you would never notice. It could be unbelievably enormous and still finite. So how do you tell? You don't tell by traveling, you tell by looking for fingerprints. But before we get to that, the universe adds a second twist. You don't even get the full map. Even if the universe has a global shape, you might never see enough of it to prove it. Because we don't see the entire universe. We see a bubble, a horizon. And that's not a technology limitation, it's physics. The universe has a finite age, about 13.8 billion years. That's measured. And the speed of light is finite, also measured, which means information can only travel so far. So when you look out into space, you are not seeing everything that exists. You are seeing everything that has had time to affect you. Everything inside your causal bubble. That region is called the observable universe. But observable universe hides something subtle. There isn't just one horizon. There are two. The first is the particle horizon. That's the limit of what we can see right now. The farthest light that has had time to reach us since the beginning. That's the 46.5 billion light-year bubble. But there's another horizon that matters even more, the event horizon. The event horizon isn't about what we can see today, it's about what we can ever see. Because the universe isn't just expanding, it's expanding faster and faster, which means there are regions so far away that light leaving them today will never reach us. Not in 1 trillion years, not ever. Those regions still exist. They're not beyond the edge, they're not behind a wall, they're simply outside our future connection, outside our causal future. And this is where edge becomes even more misleading, because the real boundary in cosmology isn't a border in space, it's a border in time, a limit on which events can ever enter your history. The universe doesn't end in a place, it ends in what can never reach you. And now here's the number that breaks people. The universe is 13.8 billion years old, but the observable universe has a radius of about 46.5 billion light years. Read that again. 13.8 billion years, 46.5 billion light years. How can something be 46.5 billion light years away if the universe is only 13.8 billion years old? The trick is that 46.5 billion light years is not the distance the light traveled through space like a bullet. It's the distance to the object now, measured in today's stretched out universe. Think of it like this. Imagine a ruler that can stretch. A flash of light starts at one end and heads toward you. While it's moving, the ruler itself gets longer. So even though the light is always moving at the same speed locally, the distance it still has to cross keeps changing. That's what expansion is, not objects racing through a fixed stage. The stage itself rescaling while the signal is in transit. Early on, the region that emitted that light was much closer. The light began its journey in a denser, smaller universe. But during the billions of years it traveled, space stretched. The distance between there and here increased. So by the time the light arrives, the source isn't 13.8 billion light years away. It's much farther away now because the coordinate grid grew while the light was crossing it. This is why cosmology has two different kinds of distance. Distance then and distance now. And once you accept that, you stop picturing the universe as a room you're looking across, and you start picturing it as a geometry evolving in time. So the third payoff is brutal. Even the part you can see is shaped by limits on information, not walls. The universe doesn't present itself as a complete object you could cross and reach a boundary. It presents itself as a causal structure, regions that can influence each other, regions that can't, and the edge you run into first is not the edge of existence. It's the edge of connection, the edge of what can ever reach you. But wait, that means something even more unsettling. Even if the universe had an edge, it could be beyond what we can ever observe. Not because we aren't clever enough, because there hasn't been enough time for information from that boundary to reach us. So the edge of the universe question collapses into a different one. What does it mean to ask about the whole universe when we only ever see a part of it? That's where the universe stops letting you bluff, because now you can see what an edge would actually imply. If the universe had a boundary, it wouldn't be neutral. A boundary is structure. It creates asymmetry. It creates a preferred direction, a place where things stop. And if there were a preferred direction, we would expect to see its fingerprints. Because an edge isn't just a line, it's a rule change. It would make the universe look different in the direction of the edge. Not necessarily a visible wall, but a pattern, a gradient, a distortion. So here's the key move. Instead of searching for a wall, we look for fingerprints. We ask, if space is curved, what would we observe? If space wraps around, what would we observe? If there's a boundary, what would we observe? Then we check. And this is where proof matters. Not vibes, not philosophy, proof. So let's do it. And when I say the oldest light in the universe, I don't mean starlight. I mean something older than stars, older than galaxies. For the first few 100,000 years, the universe was a hot, dense plasma. Light couldn't travel freely. It kept scattering off charged particles, like headlights in thick fog. Then the universe cooled, atoms formed, the fog cleared, and light was finally able to stream across space. That first free light is still here. It fills the universe in every direction. We don't see it with our eyes because it's been stretched into microwaves by expansion. But we can measure it, and it's not perfectly uniform. It has tiny temperature variations, faint ripples. Those ripples are the frozen imprint of the early universe, a cosmic pattern stamped into the sky, and that pattern gives geometry nowhere to hide, because curvature changes how that ancient pattern projects onto the sky. It changes the apparent size of features, like viewing the same image through different lenses. So the universe itself becomes the measuring tool, not philosophy, not metaphor, data, first fingerprint, curvature. And flat here doesn't mean smooth, it doesn't mean empty. It means something precise. It means geometry behaves like the rules you learned in school, at least on the largest scales we can measure. In flat space, triangles add up the way you expect. 3 angles, 180 degrees. But in curved space, that breaks. In positively curved space, triangle angles add up to more than 180. In negatively curved space, they add up to less. That sounds like a math trick, until you realize it becomes observable when the triangles are enormous. Not triangles drawn on paper, triangles drawn across billions of light years. The universe itself provides those triangles. It gives you standard patterns, known sizes, imprinted in the oldest light. If space bends, those patterns appear distorted, stretched, shrunk, shifted in angular size. When we measure it, here's what we find. Space is extremely close to flat, measured. Close enough that if space is curved, the curvature is unbelievably gentle. Flat to within a few parts in 1,000, within a few tenths of a percent of perfectly flat. Meaning, if the universe loops back on itself, the loop is larger than what we can see. No nearby curvature. No hint of a wall. That's proof beat number 1. Now the second fingerprint, topology. This one is even more direct, because if space wraps around in a small enough way, the universe becomes a hall of mirrors. The same structures would repeat. The same patterns would show up in multiple directions, not because the universe is duplicating objects, but because light would have more than one path to reach you. So you would literally see the same patch of the early universe in more than one place in the sky. The same imprint, repeated, and the cleanest signature would be matching patterns like paired circles appearing in the oldest light. So we searched the sky for those repeats, and we don't see them. No repeating sky patterns, no obvious hall of mirrors signature. And that tells you something very precise. It doesn't mean the universe can't wrap around. It means if it does, the scale of that wrap is larger than our observable bubble, too large to leave obvious repeats inside our horizon. That's proof beat number 2. And notice what all of this has in common. Curvature, topology, horizons. None of them describe a wall. They describe constraints, rules about connection. The deepest structure of the universe isn't a boundary you can run into. It's the relationship between events. What can influence what? What can reach what? What can ever be in the same causal story? That's why the edge question keeps failing. Because you're asking a spatial question about something that is fundamentally causal. Where does it end? But the universe doesn't end like a place. It ends like a limit. A limit on information. A limit on interaction. A limit on which parts of reality can ever touch your timeline. And that's also why infinite isn't satisfying. Not because infinity is wrong, but because it answers the wrong kind of thing. The real answer isn't a size. It's a structure. A universe can be infinite and still have horizons. A universe can be finite and still have no edge. The only thing that actually shows up in experience is this. Reality is stitched together by causality, not by borders. Now step back. What have we earned? We've earned a model that explains the edge problem without dodging. Here it is. The universe has no edge because the universe is not a thing inside space. It is the space. Edges belong to objects in space, not to space itself. And on the scales we can test, space is extremely close to flat. And on the scales where wrapping would create repeating fingerprints, we don't see them. So whatever the global shape is, it doesn't behave like a room. It doesn't behave like a box. It doesn't behave like something with a wall you could reach. And that's why where is the edge keeps failing, because the universe is not built out of the same logic as furniture. It's built out of geometry. And causality, so here's the final reframe cleanly. The universe has no edge because the universe is not a thing inside space. It is the space. Edges are for objects in space, not space itself. And if the universe has any edge you can actually encounter, it's not a wall, it's a horizon, a limit on what information can ever reach you, a boundary not in space, but in causality. That's the real edge you live with, the edge of connection, not the edge of existence. And that raises the next question. If the universe has no edge, does it have a shape? Not comfort, truth.